Hello everyone. Today we will solve some examples about confidence intervals. Let's start with the first example. So the question says that among various different fish, the standard deviation of heights of barracuda fish is known to be approximately 3 centimeters. In order to construct a 95% confidence interval for the mean height of barracudas, 49 of them are chosen randomly and surveyed. The mean height is found to be 17 centimeters with standard deviation of 2.8 centimeters. Construct the confidence interval. So it's obvious that it's a confidence interval question. So the first thing we need to do is write down what is given in the question in mathematical forms. For example, what is 3 in here? So what is 49? And what is 17? And what is 2.8? And also, what is this? 95%. So, first of all, since it says that among various different fish, the standard deviation of height, so it's a standard deviation, 3 centimeters is a standard deviation. Is it population or sample? So we can say that since it is previously known, we can say that it is population standard deviation, which is sigma. How about 49? 49 is our sample size, which is n. How about 17? 17 says that it's mean height. So mean height of the sample, which is x bar. So with standard deviation, since it says that the mean height with standard, so it belongs to the sample. So standard deviation of the sample. So what is this? 0.95. So we can say that it is 1 minus alpha, our confidence level. So, okay, now we wrote down what is given. Now the question is, which confidence interval is the one that I'm looking for? It's the confidence interval for the mean. Why? Because confidence interval of the mean height, actually it's written here, in order to construct a confidence interval for the mean height of barracudas. Okay, so it's about mu. So we will look for confidence interval for population mean mu. So now we need to decide which formula should we use. So the first thing you need to do is check sigma square is known or unknown. So since we have sigma, we can say that sigma square is known. So since it's known, our formula will be probability x bar minus z alpha over 2 times sigma over square root of n is less than mu x bar plus z alpha over 2 times sigma over square root of n, which is equal to 1 minus alpha. You can check these formulas that I've already uploaded on Moodle. You can check them at there. So okay, so we know x bar, we know sigma, and we know n, but we don't know z. So we need to find these z value. so they are the same. So how can we find it? First we need to draw the graph. Let's draw the graph of Z table. So what is 1 minus alpha? It is 0.95, so alpha is 0.05. Alpha over 2 is 0.025, which means these shaded areas are 0.025 and 0.025. So we need to find that Z value, Z 0.025. From the table, you can check that. First, you need to find this area, which is 0.475, because the total of these two should be equal to 0.5. So when I look at the table and find this value inside the table, I can say that this value is 1.96. So I know everything and I can calculate the rest of it. Let's change the color. So x bar is 17 minus 1.96 times. So what is sigma? So sigma is 3. And what is n? N is 49, square root of it. So mu is 17 plus this 3 over 49, 0.95. So why didn't I use standard deviation of the sample? Because I already have sigma, so I don't need to use it. Okay, after I do the calculations, I found the value is between this 16.16 and 17.84, 0.5. So the question is finished, but we need to make some comments on it. What's a comment? So what does these values mean? So we can say that under 95% confidence level, the mean height of barracuda fish is between 16.16 centimeters and 17.84 centimeters. So the question is finished.